Okay guys, today's video is over tangent lines and tangents, so that's what we're going to be looking at today. So this is 12.1, and basically a couple of vocab words you need to know to start off with is the tangent of a circle, which is a line that intersects, so this is intersects a circle at exactly one point. So in this picture here, so if you look at this picture here, LP would be considered a tangent. So it's a line that is intersecting your circle at one point, and that means you have a tangent. So we're talking about this line, LP, that would be a tangent. Okay. You also have something called the point of tangency, which is specifically the point where a circle and a tangent intersect. So in our picture here, that's point P. So it's going to be a point on both the circle and the line of your tangency. So those are the couple of vocab words that you need to know for this unit, or this section, I mean, sorry. So now we're going to look at a specific theorem about a tangent, and this is an important theorem. So basically it tells you if a line is a tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if line AB is a tangent in this circle O at point P, then line AB has to be perpendicular to that radius OP. So as you can see, creates a right angle. That's the key thing here. So kind of get a few examples using that. First example is you want to find the value of x using the fact that 117 is the central angle. So what we need to know here is MN and LM are tangents. So these are right angles. So if those are right angles, this is a quadrilateral. So that means 90 plus 90 plus 117 plus x has to be 360 because all the angles of the quadrilateral add up to 360. So you basically get 297 plus x equals 360. So x ends up being 63 degrees. So that's how you would do that problem. 2 is kind of a little bit of a tricky one because 2, you're going to use Pythagorean theorem where you have your A and B in this problem is this x and 12, but your C has to be this, has to be this whole side of x plus 8. So basically what you do is you take x squared from right here plus 12 squared equals x plus 8 squared. So you've got to get that whole thing squared, not just the 8 and not just the x. So when you do the algebra, you get x squared plus 144 equals, now this is a binomial times a binomial. So basically you're taking x plus 8 times x plus 8. If you don't know how to do that, then I suggest you go back and look that up because I'm not going to take the time to show that. But the way you would multiply x plus 8 times x plus 8, you would get x squared plus 16x plus 64. Then you would solve. Now, since you have an x squared on both sides of the equation, those cancel out. So basically what you have is 144 equals 16x plus 64. So if I subtract over the 64, I get 80 equals 16x, divide by 16, and x is 5. So that's how you would do a problem like number 2. The key thing is remembering C is this x plus 8, not just 8 or not just x. You have to combine those together. Okay, so there's that one. And then the last example we have on this page is deciding if ML is a tangent. So we're trying to decide if this side right here, okay, it's not wanting to write. If this side right here is a tangent. Well, to be a tangent, we need this to be a right angle, which means we need that to be a right triangle. So what we're going to do is we're going to see if Pythagorean theorem works. So we take a squared plus b squared, oops, and we want to know, does it equal c squared? Well, a and b are 7 and 24, the two smaller sides, and c is 25. Here you get 625. Here you get 625. They do equal each other. So yes, it is a tangent because a squared plus b squared equals c squared. Or 7 squared plus 24 squared does equal 25 squared. So that's how you find out if something is a tangent. Use Pythagorean theorem. And then the last theorem we have to look at for these notes, and then that's going to be all for this section, is that two tangent segments to a circle that share a common endpoint outside the circle, that means that the two segments are congruent. So if BA and BC are tangent to circle O, then we can say that BA is congruent to BC. That's what this tells us because they both meet at this point B. So we're going to use that to do a couple of examples. First one wants us to find the perimeter of this triangle ABC. Perimeter is the outside. So what we have to use is, if this is 10, if AD is 10, since AD meets at the same point as AF, these are congruent. So this is also 10. Same here, if FC is 8, that's 8. If DB is 15, that's 15. So your perimeter is equal to 10 plus 10 plus 8 plus 8 plus 15 plus 15, which ends up being 66 centimeters. Example 5, you have the perimeter and you want to find the missing length of QY. So basically, if this is 15, that has to be 15. If that's 17, that has to be 17. They meet at the same point. And then these will make both X because they have to be the same. So once you find X, that's going to give you the length. So you basically want to take 88 equals 15 plus 15 is 30. 17 plus 17 is 40. Wait, no. 34. And then we got 2x. So you basically have 88 equals 64 plus 2x. Subtract the 64. That's horrible. Hold on. 88. Subtract the 64. You get 24 equals 2x. Divide by 2. So x is 12. So you're just kind of working backwards. But again, the key thing to know is if it meets at the same point, like here, then the two sides, these two tangents, are congruent. So that's why we got 17, 17, 15, 15. It's not the ones next to each other, right? They've got to meet at the same point. So that's all for the notes for today. You're going to have a Canvas check to go along with this. And other than that, have a great day. Bye.